Good morning. Welcome to the second day of our training. Welcome also the people who is joining us through our live streaming. Today we're in the second day of our training. We are going to cover a very important issue, that is how our equipment can perform the size measurement. You know that both FMF 1000 and 900 are equipment that can provide size information, and to be able to do that, the equipment has to go through a process, a mathematical process, to analyze all the targets, and we will go through that. The graphic representation of the size calculation is the histogram, is a bar graphics. Is a standard in the industry. When you see all equipment that measure targets, the normal way to express the result is a bar histogram, in which you have a percentage in the y-axis and size in the, or TS in the x-axis. So we will go through that, the variables that affect the target measurement, because target measurement is can be very difficult depending on the conditions on the environment, the way the fish is presented. If it's a scattered fish, is not very dense shows, then the measurements is easier. But if we encounter very dense shows, the measurement can be very difficult. So we will see how these variables affect the measurement, and we will also cover a situation that can happen a lot, which is multimode histogram, and we will see what means. But multimode histograms are histograms in which you have 2 or maybe 3 modes, peaks. You will see graphically it's very clear. That could mean that you can have different populations inside the histogram. You can have different species. You can have juveniles of one species inside the graphic. So it's very important to understand that, because it affects the average, the mode. And we have a couple of solutions in the system for that problem. And finally, we will discuss how is the process, of the adjustment of the measurement, because it's true that all the system that we deliver out of fabric, the factory, we provide with a standard calibration. Remember that we discussed calibration yesterday, but then there are some situations that can affect measurement in the environment in which the fisherman is working, like water temperature, salinity, how much life is present in the water, the density. All those variables can affect, and in the end, you will have to need to perform a fine-tuning, and then in order to do it, we recommend a process it's very intuitive and simple, but I want to explain it, because sometimes when I go through this, people don't clearly understand what we mean when we say, okay, you have to measure the fish. Like, actually, you have to measure it. And they say, okay, how is that I have to measure it? Yes, put the fish with the centimeter rule and measure it. It's like that. And take a sample and do it. We hope that we can do this in 1 hour and a half. But this subject is very important. So I have to extend a little. Maybe I will do it because it's one of the most important things that demands support after selling our equipment, is to fine-tune the histogram and adjust the size measurement when the clients demand it. The problem of size measurement using an echosounder, it is a problem. The echosounder do not measure size directly. It measures target strength. Target strength is the amount of energy received from the reflection of the transmitted signal. We transmit a signal, we receive a backscatter from the object, and that is the target strength. Target strength is expressed in dB, decibels. And then the computer, the CPU in the echosounder, converts these TS into size using a formula, which is generally accepted formula in the market. But you will see that the formula is not is the same formula for every species, but you will see that each species has different values, a constant that assumes different values for adjustment. So you use the same formula, but it's not the same for every species. Now you will see it. First, we would like to make some disclaimer. TS is I use a lot this book, which is the I recommend you to buy it if you are interested in fisheries acoustic. It's like a Bible for people who study this subject. Is the book from John Simmons and David McLennan, two Scottish guys that studied a lot. These people invented the process of calibration with the sphere that we use normally in the industry. So these two authors defined the TS as a stochastic variable. They say one which exhibits a range of values in repeated measurements of apparently similar targets. So this means that it's random. You will measure the same target in different days, maybe, or in different water conditions, and it will be the same fish. And it could happen that you can have different values. This is not to say that TS will not work. It is to say that you have to understand this because it will happen and can happen. It's most common that you think. There are many variables that will affect the TS measurement. The first one, and the most important, I think, is the fish species. Fish species definitely affect the TS measurement. That's why we have a constant that is different for each one to adjust it. And that there are different reasons, but the main one is what we measure from fish is actually 80–90% the swimming bladder. So the size of the swimming bladder shape, that will determine how difficult or easy it is to measure one fish. The environment, water temperature, salinity, the season of the year, the geographic location, the density of the fish also is a very important variable that if you have a big concentration of fish, then you will not be able to get single targets out of that sample that you took, so it's going to be very difficult to measure. The depth, you will see now that the deeper we go, the more difficult it is to measure because you are increasing your sampling area. So remember that, I don't know if we talked about, but always remember that to be able to measure one fish, the system needs to have what we call single targets. because if you don't identify a single target in the sampling area, then you will see later that you can have situations in which the shape of the target is affected, the size of the target could be wrongful measured, and obviously the depth decreases the possibility to measure and increases the difficulty. Another thing that can affect the measurement is the tilt angle of the fish. So you measure from above. So if the fish is not presented totally horizontal, because it's swimming up or swimming down, that will affect it. It's a very intuitive concept that affects definitely the measurement. There are research about this, that even like tiny inclination angles can have a large difference in TS measurements, difference in the ranges of 15 or 20 dBs when the target is not horizontal. These two variables, are colored in red: acoustic resolution of the echosounder and calibration and compensation, because from all this list, these variables are the only ones that we can control. The others we cannot control, are given to us. So see how this is very difficult, because there are a lot of variables that we cannot control to get a good result. We can only control these two. We can only adjust the pulse width, we can only adjust the transmission mode to get more acoustic resolution, and we can, remember yesterday we talked about the calibration, we can have a good calibration in the equipment that will improve the accuracy of the measurement. The formula that we use to convert TS to size is that one. Formula has a logarithmic part, and that formula expresses the direct relationship in between the target size and the TS. And then you can express mathematically the target length in relationship with the TS easily. So, but the formula has a constant that we call V20, that this value is changes with its species. So when you see a sounder that applies one single formula to all species, then you know for sure that there's a bias there in the measurement. It's not possible to apply one only formula to measure all fish. And you will see that sometimes that V20 varies a lot. For example, in the case of mackerel is a fish with no swim bladder, and the expression in sound of mackerel is very low. So if you measure mackerel with the same formula that you use for cod, then you will measure like, I don't know, 35 centimeter mackerel, and it will say 6 or 7 centimeters. I've seen it. It's that way. So you can check it mathematically. It's also easy to do. So different V20s, you see there the differences in between species. Atlantic mackerel, swim bladderless. The constant is 84 dBs to 86, while with cod is 64. So the difference is huge. Yeah. So this is also a correction in dB applied to a logarithmic formula. So it can be easily added. So you see there are different species. The most common one, what some manufacturers like Simbra did is like they created what they call a white fish species, a generic species in which they cover all these I don't know, cake, cod, blue wheating, some compromise solution they find to cover different species. And in the ES80, they offer herring, they offer whitefish, which covers cod and all these type of fishes. They offer anchovy. What we offer is a longer list of species, and also the possibility for the user, we will see it, but the user will be able to create new species. I don't think the user will do it. I think that you will do it for the user, but we have had some cases in which here in Spain, users managed to create new species because they understood the way the system works, and they tried with different adjustment, different B20s, more custom more custom constants for adjustment. So the thing is here, you have to remind is there's no one formula to all fish. Yes, formula is the same, but since the constant varies with the species, you will not be able to measure up accurately, I'm sorry, all of them. If you apply one constant, then depending on what you're measuring, there's going to be some bias. In TH measurement, we need to, as I told you before, we need to have one target separated from the other at least half of a pulse length in water. A single target is the one that is isolated from others in the sampling area. So if you don't have a target isolated, the system will, whenever you analyze targets, they go through different algorithms. It will analyze the signal, and perhaps you will lose it because it doesn't go through the algorithm. You'll see clearly here, in that graphic here, that's the transmitted echo, the transmitted pulse, I'm sorry, and the received echo of one target. You see that you receive the same signal in this case, but if two targets are in the same range, then the signal will be added. And you can measure one fish as it's twice the size of the real one. It can be the possibility that two echoes shade each other and you don't have any information from any of both. It can be, depending on the position of the echo, that you receive an average of the two targets. And then it's also possible that if you have many targets, you will receive at random ranges within the sampling area, you will receive a signal totally damaged that you will not be able to use it to measure size. So this happens. A constructive interference or destructive interference can have. If density is too high, this case here, if density is too high, the fish is very tight, then you receive this. The system analyzes the signal always for every target and decides, this, I'm going to take it to measure this, I'm going to not count. So remember that we mentioned the sampling area. Sampling area is given by the angle of the transducer and the vertical resolution. So we have more than one fish in the sampling area. Then it will be difficult to measure it. But the thing is that since we have, we can have a good ping rate, then we increase with good ping rate, we increase the chance of measuring. So the biggest the ping rate, we increase the chance to get those targets isolated enough to measure it. If your system is slower, if you're going deeper, then the sampling area will increase. So the chance that we have isolated targets in that sampling area decreases. And also the ping rate decreases. So the deeper we go, the worse is for measurement. That doesn't mean that we cannot measure, I don't know, 400, 500 meters. We did it. We have a demo. You've seen a demo in the exhibition at Navalia. We show it here, in which we were measuring fish at more than 400 meters. And so it's possible. It's not that it's not possible, but it's very difficult. So, I'm sorry? It will be less accurate. Yeah, of course. So, but remember, if the target backscatter doesn't meet the requirements of what you consider a measurable echo, the system will not count it. And this slide explains it. The deeper the sampling area, as the pulse advances deeper, the sampling area increases the size. A bigger sampling area means that more target can enter, thus the probability for good measurement is lower. So this, keep it in mind, because when we talk with, we had this situation in which one fisherman said once that our system was not working properly, and he showed me like a picture with small fish, tiny 10-centimeter fish. And if you see the picture, you will see like there are so many of these small fishes. He was fishing like in 300 meters range. So picture a 10-centimeter target at 300 meters. So you can understand the backscattering of that target. And then there were some big fish. So what the system caught was the big fish. The small fish, because you have to understand that the echosounder in order to be able to measure the target, must enter the receiver. If the target is small enough not to enter the receiver, then you cannot measure it. So sometimes these things can affect the result of the measurement, and then you have a complaint from your client, a picture saying, oh, this is a small fish, and it's saying 25 centimeters, and this is a very small fish. Yes, you're catching small fish, but you're also catching 25 centimeters. And this is small fish. The system is not measuring it because you're fishing it at 300 meters. It's like there's a limit for the sensitivity of the receiver. There's a limit for the targets that the receiver can process and can receive. The high density, when we have situations of high density, we always ask the client, the skipper, to measure that target, not using an area, not selecting an area that covers all the target, but instead trying to make smaller sampling areas and move that sampling area all around the shoal, because in the shoal, generally speaking, shoals are dense in the center and less dense in the edges. So sometimes it's advisable that you move the selection area all around the target, not go to the center. If you go to the center, you can have situations in which targets can be, you can have in the center, you can have this kind of targets. This kind of targets will go through the algorithm. You can see targets like double size of what real is, because it's very difficult for the system to identify this situation when it happens, because the signal is not broken, it's good. is added. So when this happens, and if you go here, the chance of getting that kind of targets, added targets, is bigger. So we always recommend that when you have dense shows, you use the selection in the edges. You can use a big selection and select all of them, but when you do that, you increase the chances of getting these bad measured targets in the center of the show. So this is like an easy rule to explain to the fishermen when they are trying to apply the selection area. Swimming bladder. We will see it in other slides, but you have to understand that the swimming bladder is what represents 80% of the measured signal of a fish. So only the flesh and the bone is only 20% of what we receive from the signal. So 80% is coming from these gas-filled little sacs. There are actually two inside the fish. The fish uses the swimming bladder to alter the depth easily, not using the tail and the impulse, but using the physics. They fill this swim bladder with gas. Sometimes they fill it with a mixture of gas and wax, but generally it's gas. And as they inflate the swim bladder, they increase the buoyancy and they go up. And if they do backwards, if they eliminate the gas, they compensate the pressure and they go down. So this is very important to understand, because if the fish has no swimming bladder, then the signal from that fish will be much lower. And the thing is, with the swimming bladder fishes, that you can also have these situations in which you measure one fish with swim bladder one day at one particular depth, like, I don't know, 200 meters, and then you fish it, then you measure it at 400 meters, the same fish, same size. Because of the change of the size, because the deeper you go, the smaller is this swimming bladder. So the same fish will give us different target strengths if it's measured at different depths. This is something that we cannot identify with the system because it's very random. It depends on the behavior of the fish. Here we see like X-ray images of mackerel and pollock and saithe, two fishes that has a swimming bladder. You see the importance of the swimming bladder inside the body, and then the mackerel with no swimming bladder at all. And remember that when we measure the fish, we measure it always from above. So when you see the picture of this X-ray from above, you see the importance of the swimming bladder in all the composition of the body.
This would be like a diver.
Yeah.
And also with the suit, but the bladder might matter.
Yeah.
Still it won't, because to stay on a specific depth, you will have a specific buoyancy.
Yeah.
So you can actually compare the depth to the bladder as well.
Yeah. But yes, but well, here you see the what I told you, the importance of the swimming bladder. So the pointed line is the response of only the swimming bladder, isolated. And then the solid line, the more thick line is all the fish body, the whole fish, I'm sorry. And this line down here is the body. So the swimming bladder is almost all the response in sound. It's very important to understand that that particular part of the fish is what determines what we see as target string is mostly that sac inside. And the reason why is because, as we explained it before, gas or air in the water is a different media, different sound speed, and then it's almost a perfect reflection of sound. So the sound will not go through the swim bladder, it will reflect almost perfectly. It's like an air bubble. Okay. Different species has different response in frequency. That is also very important to understand, because this helps us to understand, or maybe to it will help us to identify the species that we're looking at. So the species is one of the, as I told you before, one of the most important variable, because it's no two species have the same response in sound. So it's to considering the species, but you will say, okay, how do I know the species that I'm fishing for? Fishermen, they know, and they know because they apply their experience at looking at the echosounder. They know because they are fishing in the same area, in the same season of the year. They fishing in the same grounds for many years. And when they get used to the echosounder, they know the species that they are fishing for. Even we are not fishermen, because we look echosounder screens all days, every day. So when you do that, you train your brain to read the information on the screen. You see the shape, you see the depth of the trace, and you see that, and you understand, and you can identify species. And when you identified it, you apply the right formula to measure it. You see here the response in frequency of the anchovy and the sardine. I brought it because we compare it. This one is the response in sound of the cod. You see, in low frequencies, the cod will respond high, and as the frequency is increasing, the cod response in sound will diminish. So the curve of the response in sound of the cod will be like this. Instead, anchovy will be like this. To understand this is very important, because we not only use the FMF 1000 to measure, that is the split beam sounder, but we also use the 900. And the 900 uses the principle of dual beam. Remember that we have two transducers, and what we analyze is the behavior of target in one transducer and the other, and then we decide where the transducer is located, the distance of the target is located, the distance from the axis, depending on the response in sound of each species. So if you have a species that responds in sound in this way, flat, like anchovy or sardine, and then you have this species that the response is this way, very pronunciated, very different, then it can be the case that with this type of species, dual beam will work better because you will not have differences in between the low and the high band. Instead, if you use it to measure code, perhaps, then you will have to compensate this different, but there's not possible to compensate the different all the time. So the performance of the system using it for measuring fish like cod or many whitefish behaves this way. So I will not advise to use a dual beam system to measure this type of fish unless you use a different dual beam transducer than we use. In the past, there were some dual systems that used only a single frequency. You can have dual beam on 38 kilohertz, for example, only in that frequency in CW, and because they use a transducer with two ranges of elements. They use a small transducer in the center, same frequency. Then they extend the elements at the edges and they create different angles with the same frequency. So if you have this kind of transducer in 38, then it's okay for the code. But we use the 599, like Furuno does. The reason for using that type of transducers is because they are very good transducers. They're very reliable. They are very flexible. They allow you to use it and reconfigure the system, use it in different frequency, use it in chirp mode. But the side that is not so good is they use low and high frequency bands, and we use these two bands to make the dual peak. And when using this type of transducer, which are more affordable and reliable and flexible, instead of using a traditional dual beam transducer, has the disadvantage that some species may not be good to measure with this type of systems. So if you want to advise or recommend a client a good equipment for size measurement of code or site or haddock, then this will be a split beam sounder in a fixed low frequency, like, or in a range of low frequencies. Like there are some transducers now, the range is from 25 to 45 kilohertz in chirp mode, or maybe a single frequency in 38. But instead, if it is a sardine or anchovy or herring, midwater pulsiner or midwater trawler, maybe a 900 equipment could be enough, because you will not have many difference in the target response in between the low and high band. And you can perform a successful dual beam measurement with that type of fish. And also, because anchovy and sardine mean pelagic fish, remember that pelagic fish always behaving presents in big shoals, very dense, and since they tend to swim at a certain speed, then you will see that all the shoals, if you have a sample of the shoal, you will see that there's no big difference in between the smaller and the bigger, because the small one cannot swim with the big one. So all the shoals tend to be very, there is no difference in between the small and the big. So it's a small variance in the size in the shoal of pelagic fish, generally speaking. Instead, the whitefish that behaves more in the bottom, like bottom fish, like a cod or haddock, they have smaller aggregations. Sometimes they can be very dense shows of code, of course. But this is generally speaking, they present in more less dense shows. And so it's easier to measure, but not with a dual beam, perhaps. Remember that we talked before about the tilt. This is more graphic when you see the difference of the wave when it's inclinated or when it's horizontal. So the difference can be very determinant. So we've seen that sometimes the anchovy can behave in a different way in the night or during the day. So depending on where you're fishing, the type of the anchovy that you're fishing, the place, geographical place, during the night, the anchovy may swim up, and during the day, then they swim horizontally. So it's not the same if you measure during the night or during the day. So that's also another thing that can affect the result of the measurement. Another variable that we spoke about yesterday is the calibration. I'm not going to go through the calibration again, but if we have a properly calibrated system, the result of the measurement, of course, will be better than if you have an old legacy transducer that may have a part of the transducer architecture that can be damaged or low performing, so it's not the same. Okay, we will explain now what is the most important tool that represents graphically the size measurement. It is the size histogram. The size histogram is a bar graphic. In our case, the histogram it gives the not only the information about the mode or the average. We don't use a regular average. We use a mode, which is the value of the most representative size of the mode. So it's not only an average, because if you do an average, the value might not be real or realistic. So in our case, we also provide the units that the system uses for measurement. And this is very important because it gives you a hint of how good is the mode that you calculated up here. So when you see 17.2 centimeters here, it's not the same that down here says 2 or 3 targets. Because what's the accuracy of that measurements if you only measure 2 targets or 3? But instead, if the sample that you use is big enough for you to consider that it's reliable, then this number will give you a hint that you see quickly a large number here, then you understand that you can rely on that measurement. This is not the number of fish that there is down there. and I make this clarification because I had a client that was saying that he multiplied all the screens and he did, I don't know, very complicated mathematics to calculate using the units in the histogram. And he said, oh, well, I fish a lot more than that. Yeah, and told him, yes, of course, because these are the units that the system could measure. And can be the case that that number are the same fish measured like 2 or 3 times, because you have a certain ping rate, and you can have the case in which you measure one fish, and then in the next ping you measure it again, and in the next ping you can measure it again. So this number is not good to relate it with your catch, because it's not what you're going to catch. It's not how many fish is down there. It's how many fish, how many samples the system uses to calculate the mode. And the only use of this number is for you to quickly understand if you can rely on this mode here. Not all individuals in the selected area are measured, some are discarded, they don't meet the requirements to consider a valid target. Remember that a valid target is one if the system can measure it's not broken, it's not damaged, the signal is not broken, not damaged, not constructive or destructive altered, and if they meet that requirement, that those are valid targets, others are not considered for the average because they are not within the green vertical. Well, here are red. We have these vertical lines that we use. I will explain it then later, but one of the solutions that we find for improving measurement is that we apply to the histogram a cursor or vertical lines. So we allow the user to adjust the area in which they consider that they will measure. Here, for example, in this picture, you will see that the user selected the area, this area here, because this here could be bait or small fish. And if you don't have these vertical lines, then the average will be much smaller because the system will take all these fish, small fish bait into consideration and will alter the size. Okay. This, you see here that we have clearly two modes. Two modes means this is a multi-mode histogram. When we measure fish, we will encounter in reality that sometimes we will have this problem of the multimodal histogram. That is more than one peak. When we have one peak, what we call a Gaussian shape, clean. So if we see this bell shape, then this is the ideal situation for the system to calculate the mode. Then you have the mode here, and that's everybody's happy, and the average or the mode will represent the real value, and this is good. But then it can happen that in reality you don't have one type of fish or one size always isolated, and you can have situations in which there are more than one mode. We call those histograms multimodal histograms. There are more than one. There is more than one peak. And then if you use the normal procedure to calculate the mode, perhaps it will give you a value which is not real. So what we do is that using the vertical lines, then we allow the user to select one part of the histogram to measure, or maybe we allow the user to use a species selection in a second area. So there are two ways to treat or to deal with a multimodal histogram. There is one way, that is the vertical cursors. You have one histogram. You don't open many graphics, only one graphic, and you treat it with the lines. But then you can open a second area, and that in that area, select the species that the particular species that you want to measure. And I selected, in this case, cod. What the system did is, okay, code is in this area. And so I am putting the second area here, and it is the same as you apply the lines here. But you don't have to use the lines, you use the species, and then in the selection, it will give you all here, all the signal coming, all the targets coming, I'm sorry, and here only the ones that are in the area of the particular species. So there are two ways to deal with multimodal histograms: the vertical lines and the species selection, opening a second area. I explain this because in FMF 1000 split beam, you will have the possibility to open a second area and to have a species if you have split beam mode. This is the standard provided with the equipment. In case of 900, if you buy the sounder 900, we meant the 900 to compete against the 1900 from Furuno. And 1900 from Furuno has no species selection, only one bar graphic, and that's it. So what we did is we sell the species selection in the case of the 900 as an optional. But if you don't buy the species selection for the 900, then you can use the vertical lines to deal with the multimodal histogram. So you have, even you don't have species, you have solution for this problem. It will depend on the client that you are dealing with, that he wants to mesh into select the species and measure. When we began, I'm sorry, here in Spain, dealing with small pursainers, they were fishermen that were not used to operate this system that calculates size with histograms. So the problem was that they didn't understand what species mean. That they thought that the system will tell them what is the species. And it's backwards. You have to tell the system what species you need to measure. It's not that there are systems that we will discuss it if you want, but there are systems that can give you a hint of the species, but this is not a species identification. This is you telling the system, I want to measure this with this formula, with this constant, remember? So I will use a species code that has the B20 for code, and that applies the maximum and minimum size for code. That will give me, like if you put different lens, then I will see through the lens of code, okay? But this, to understand, was very difficult to make the fishermen understand this concept, because they thought that, okay, but this system is giving me information of the species. No, you have to tell the system. You, because your experience looking at the echosounder and you fish in the same place as always, and you know how the shows are presented, then you can tell this is mackerel or cod or whatever. And then you tell the system, use the formula to measure cod. This may seem a very simple concept, but for the client using first time this type of equipment was for us a task to explain. So sometimes perhaps it might be the case that for you to offer this echosounder, I will start with a simple concept, only one graphic. If we have this problem of the multimode histogram, then we have the vertical lines to solve it. Then you will tell, okay, this is bait, and here is your fish, put the lines here, and you will have a good result. If the client wants to have more precise information, if he wants to perform a better measurement because he wants to apply the correct constant to the formula, then you offer the client the species package. which is another license that we have. We did it that way because not all the clients wants to use species, and because Furuno doesn't offer it. And for you to quote the same system, you can quote and offer the tool as an added value, in not offering like a different specification that Furuno is not offering. So what we did is, okay, you offer the same tool that Furuno is offering with the advantage of the vertical lines. Furuno doesn't have the vertical lines. You see the 1900G, you will not see no vertical lines for the bar graphics. Then that's an advantage. And the species, you don't have it in Furuno either. So when you offer a client a target measurement solution, please keep in mind that if it is 1000, a split beam sounder, it will have all the features, all these features included, the vertical lines, the species. And if you offer a 900, then it will be like a normal 900 with a size indication. We have only one histogram, the vertical lines, and then you can add the specific species formula package. This explains the effect. This slide explains the effect of applying one species here to is a visual fishing for cod. You see clearly here that we are selecting the cod species, and the system is like representing down here one part of this this generic graphic. When in this area 1, with this particular configuration, you see bars for all the targets coming into the area you selected. You select that area, you see all the targets in TS. Then down here you open a second area that you measure a part of this or information, and you apply the formula for code. Remember that I told you that not only the listed species that we offer are available, but you can create new ones. And you may think that we will never use this, but we use it a lot because we rely on the information of scientific institutions to create and configure species. But sometimes this constant, remember that the formula that we saw, this formula here, has the B20 constant. These B20s are listed by the major scientific institutions in the world. They use it because they share information with each other, and they standardize the information they share. So they provide all the B20s, so you can use it. But it might be the case that we've seen it in Turkey, for example, that the anchovy in Turkey, because of different factors that affect the flesh and the fat that the anchovy can have in the body, then the constant for the anchovy in Turkey may vary. So you have a Turkish anchovy. So then I'm sorry. Then I wanna go back to. Then it will make more sense to create new species, because I want to create the Turkish anchovy to make the Turkish fisherman to measure more accurately the target. Here you see this image shows the adjustment menu, the adjustment window of the histogram. And if you click the settings button in this menu, in the part of specific part of a species setting, if you have it available, if it is a 900 and you bought the species package, you will have it available. If it is a 1000 split bin, you will have it available. You can click in that button and you will open the menu to create or edit existing formulas of existing species, or create new species. These slides explain what I explained before, the vertical lines. Vertical lines it can be adjusted by clicking on the line and move it, and also can be inside the histogram adjustment menu. You have a box you can click in which you can click and enable the cursor lines or the vertical lines, and then you can move the levels of that lines, not clicking on the line, but using those selectors here. So the minimum and the maximum level. And then in this menu, you will also have the a selection of TS or size. You can make one particular histogram to be expressed in size of TS. And here you will have some parameters that you can adjust on the histogram, like the bar resolution, what means each bar, if it is 1 centimeter per bar or 2 centimeters, 1.5, the resolution, and the maximum percentage. Sometimes you have this situation in which each bar doesn't represent more than 20%. And if you leave this in 100, bars will appear like small here, and you will not see it. So if each bar, this seems to be very basic, but we made, sometimes we have service requirement for this, because people maybe touch this maximum percentage, they put it in 100, and then since the bars are 20%, they seem, yeah, they represent very small. And then there is this correction here in centimeters that you can apply if you see that the measurement you're receiving you're getting with the equipment is not accurate. Then you can apply a correction here. This will apply only to the histogram that you selected. It's not for all, it's for this. So you can apply a specific correction to one histogram that you use for one species, not applying to other. We use this only after we found that there is a constant and repetitive behavior of the measurement. Okay, if we always measure and we identify that the system is always measuring 2 or 3 centimeters smaller than real, we use this correction. We don't use this correction like I make one catch and I guess, well, this is, and I correct it, and then I make another catch, and then the size is smaller. No, we have to identify a trend. Yeah, we have to identify a trend. How do we do that? By measuring the fish. And it seems to be like a very basic concept. But I have to explain people on board. You have to take a sample and measure it. Oh, do I have to measure it? Yes, because I have to know if the system is correctly set it for your specific environment, the specific variables that you have there where you are measuring. Remember that long list of things that can happen to my measurement here in my ship. I could have I can have many things that can affect that result. So the thing is, I have to confirm and correct. And this doesn't mean that the equipment is not adjusted or calibrated, because one critic that I receive is they say, okay, but you sold me a system which is not adjusted. Yes, the system is adjusted. The system is calibrated with the sphere target. And the sphere is when you buy a scale and they put this small, tiny weight and you calibrate the scale. But then in case of this measurement equipment that deals with sound, we saw that there are many, many variables that can affect that result. And then we cannot do like selling a GPS or a VHF radio. We have to deal with the adjustment. This is something that comes with selling a target strength measurement equipment. It's not like selling other equipment. It's going to involve some distribution backup, some distributors backup to the client, a service to the client, because it's not going to be like out of the box working, and it's going to take some effort from the distributor and some patience from the client. We have situations in which the client wanted to adjust the equipment even before the first sketch, and guessing, no, down there is using the tumbling fingers rule. No, you have to explain the skipper, explain the client that this is professional measurement equipment and demands you have to take care. It's not that you're guessing and adjusting just by the feelings that you have. You're going to fish 15 centimeters and then I adjust it to 15 or 30 centimeters, whatever. But you buy size measurement equipment because you don't know the real size. So the thing is, you need to have confirmation with the catch of the real size that you have there, and then perform corrections. It's a good practice to take samples, take notes, and keep records and pictures of the measured fish, and not only for the skipper and the fisherman, but for us, for technicians, to have information for better adjustment. And this.
Now, it's important to clarify that we calibrate the system with the sphere, but the sphere have the same behavior for the whole frequencies. So
Almost the same, yeah.
Almost the same. Yeah. But as you say, the fish have different behaviors in front of frequency, and the species is the same, because it's not the same species in some part of the world and the other one. Like we have an example of the mackerel with bladder, and the other is without bladder.
And
so
you have mackerel with swim bladder and mackerel without swim bladder. It's a species of mackerel in Japan that they have swim bladder, and there are species of mackerel that normally doesn't have a swim bladder. So it's it's tricky. Sometimes you have to consider many things. It's not like you buy this and it will be like a plug and play system, you know. It will demand some. This is very important. I cannot stress it more. It's when you sell this type of equipment, you have to understand that this comes with the the deal. And you have to consider it, because if not, then it will happen that you will say, okay, I sold this echosounder, but now I have to work, I don't know, 10, 12 hours, go on board and take care of this guy who actually measure the fish and take notes. Yes, you might have to do it. Sometimes it's only, I don't know, 2 or 3 catches that you measure and that's it. Sometimes it demands a little more effort, but and then what happens is that when you adjust one, then you have like 10, 15, I don't know, 20 other vessels that they fish in the same area. They have the same installation, same transducer, same echosounder. Then you can replicate the adjustment to other vessels. But first time, it will always demand some work from us, from the technician, to advise, to teach the client about this. And then when we know, we apply correction. Then when we know, apply correction, not applying corrections based on guessings, because we are buying equipment for measurement. So that means that we don't know. This seems to be almost a stupid concept, but it happened to us.
But if you are if you are to measure fish after the catch to
Yes.
compare, then you should probably use like long lines or maybe trawl. If you use nets, you are kind of sorting the fish before the catch. Yeah. So the small ones get through, the big ones don't attach.
Yeah.
So
yeah, that's.
So you need to know what you do before starting with this as well.
That's totally true. Yeah. I mean, it's and there's also another thing that you have to consider is that sometimes you catch what you measured, and sometimes you catch more than you measure or different than you measure, because you with the echosounder you measure this show, but it can be the case that it's not the one you catch. It's very difficult to be sure that you actually measure the one you catch. And of course, as you said, with trolling, sometimes if you have a device that selects big fish and let the small fish to go through, then it can happen, of course, because the sounder will be measuring all of them. It is smaller than the big one, yeah. And you have to consider this, and this is difficulties of the TS measurement. It's not it's stochastic. TS is stochastic, random. It's good for the situation. Then the situation is different. Some variable change it. Okay, we have another situation and another set of values for the same, perhaps for the same fish. So, and please understand this, because the one thing that I want you to fix in your mind after this little presentation of all the complications of measuring TS, swim bladders and bones and flesh and B20s and complicated concept, is that TS measurement is very difficult. And the acoustic tool for measuring it has its limits. Acoustic has limitations, and to understanding this limitation, you calibrate not only the echosounder, but the client expectations. It happened to us that we sold equipment for TS measurement for first-time users, and these guys' expectations were so high, they thought that, okay, they were investing what for them was big money, and they wanted a big result. And this is not an exact science, I'm afraid. It's affected by many variables that we saw, and the distributors and technicians' job is to make the client understand what can be done with TS measurement equipment and what cannot be done, and what situations may arise that may happen that it will make impossible or inaccurate the equipment to measure.
Yeah.
Customer need to understand that the sounder may be very expensive, but it's not miracle ground. It's only tool.
It's only a tool, yeah.
Which must have to understand him what is it see.
Yes, and also please invest some time in it, because you invested money on it, and then put some time on it. Read the manual. I don't know, spend some, I don't know, 15, 20 minutes looking at it, try to understand it. If you don't know, ask. But sometimes the users are like, they need to have an immediate solution, and then they will have a solution, but it will not be immediate. It will be like a process in the middle to get the result that you want.
But it's still gonna be a miracle, because you will get some information. It will not be totally false.
No.
It will give you a signal that you can use. So I have like a couple of friends fishing with long lines, and they have a competitor which are using the ES80.
Yeah.
And he always catch more and bigger fish,
Yeah.
because he can use even the average whitefish selection. He can still catch bigger fish. So
I remember, yes,
Yeah.
it's true. What you say is totally true. I remember once we were to Chile to present our system to a big company in Chile. This company was in a project to install size measurement sounders to anchoveta fishing vessels. Anchoveta is like a sardine. It's a big anchovy from Peru. They use it for meal and oil production. It's not a human direct consumption fish. It's used for processing. So it's a big fishery in Peru. But this company wanted to provide small family-owned boats with this new technology, because they identified that when they installed this equipment to their own vessels in the company, they improved, like they went from 30 to 35% juveniles in the catch, down to less than 10%. So this is no miracle, it works, but it will demand. Yeah, well, when you think that, what you say is true, when you think that you are measuring one fish at 400 meters, but it works. I mean, it's science. It's not. I was talking with a friend of yours, Dimitri, through WhatsApp before coming here, and I was talking about this particular subject, the miracle of target strength measurement. And there's no miracles. It's science, actually. You will need some things that you will need to understand, that some things you will be able to manage, but some others are given, and you have to adapt to that variables that are given to you. Okay, here it is coffee break. We are on time. It's almost a miracle. We did it on time. If you have any question, related with this. It will be very important if you have questions, because it's this is like the central subject of. I wanted to dedicate half day to this because it's. I don't know how to say it. It's when we sell these echosounders, the thing that is different from other normal echosounders is this: is that you can measure target strength, and you can measure, and in the future you will be able to identify acoustic signature. You saw the prototype that we have in the Navalia. So this is very important, because this is what makes this equipment different from regular echosounder. So if you have any question, I will be happy to answer. If not, if the streaming people have any question.
No, just Dimitri makes some comments, like you said.
Okay.
Yes, it's a
The
problem.
miracle of target strength measurement.
Exactly.
Yeah.
Yes.
There's no miracle. You measure this tiny. Oh, here is a good one. This is a model of the swing bladder, and you see the red ring here is the place where the swing bladder is. So it's the biggest value in TS reflection is where the swing bladder is, and what you measure is that tiny gas filled sac inside the fish. And it could happen if you have enough vertical resolution, if you are working with chirp, that you can have even, we didn't experience in the practice, but I read some scientific papers about it, that you may have like two readings from different parts of the same fish, if you have enough vertical resolution. So yes, it works. It works. If you know that you are dealing with different variables that you have to keep in mind, that you have to understand and to deal with, and you manage to adjust your equipment to go through this variable, then the result will be good. If you don't understand it and you think that you're buying an 100% totally infallible system, then you might be disappointed, because that will not be the case. And this is the reality with all manufacturers. It's not that we say it because we are not Furuna or Simrad. No. This is something that happens with the technology. Okay.
One question. Sorry.
Yes.
We go back, yeah, it's like the top, yeah, where you have the top one, that's to adjust the size. What's the resolution? What the second?
Our resolution is you adjust each bar of the graphic represents one value. It could be TS or size.
Yeah, so
Then the histogram is a bar graphic. So I will explain this because I assume that not all the time is correctly understood. We have percentage here,
yeah,
and we have here could have TS or size,
Yeah.
centimeters or inches, whatever. So each bar here represent the percentage of the targets that are this particular TS. Okay, let's say here is 10 dB or minus 10 dB or minus, I don't know, is minus 20 dB. I'm sorry, I'm putting it in the wrong way. Let's say this is minus 70, minus 60, minus 50, minus 40. So what the system does is make a table, and it classifies all the minus 70s and all the minus 70, let's say, are 10. So 10 out of 100 units. Totally, I measure 100 units, an example. So 10, it will be 10%, okay? And I will draw a bar here. What you adjust with resolution is, if this only means 70, it could mean 70, from 70 to 72, it could mean from 70 to 74. So the resolution is each bar, how many different sizes includes, okay? So this could be steps of 1 dB, or could be steps for 2 dBs, 3 dBs. So if you increase that number, the bars will be thicker because you are putting inside the bar more sizes. We normally use resolution of 1 centimeter, and the bars, each bar will represent, okay? Any other question? No? Do you want to, blessing. Do you want to, we have a little time available to discuss any hardware because we discussed yesterday hardware at the last hour, and maybe if you have some question around the hardware, you can ask it now. It's feel free. If not, remember that we will provide service manual. It's not finished yet, but it will be available soon. So we will send the service manual to you once it's ready. We're working on it. And but now we will give you a gift that we will take with you. That includes also you will take your training material, but you will take also the user manual of the 900 and the 1000. So the service manual will be available. We will send you to a PDF file for you to have it. In the manual will be, as I told you yesterday, will be plenty of information about the testing points and testing results that you may expect about this may expect to encounter in these testing points. So, but if you want to ask anything about the hardware or whatever, here is a Q&A for all the training. So if you feel that you have any doubt for all the subject that we cover in this training, is now the opportunity to ask, and we will go back and analyze. Have any questions? Tom? Yeah. Yeah, I want to clarify this because it's what Tom says, and I might not be clear enough. Yesterday, we've been going through the windows in which you can adjust the transmitting and receiving bandwidth, and we are not saying that you have to have different bandwidths for transmitting and receiving. Normally, you have the same bandwidth, but it might be the case, and if you don't touch anything in the system will have the same bandwidth for transmit and for receiving. But it might be the case, it has a very technical explanation that you and Emmanuel were discussing previously. Is a very electronic engineer and mathematics explanation for sometimes might be the case that it's better to reduce the receiving bandwidth, but we are not saying that it's mandatory to adjust. Normally you have same value for transmitting and receiving. I want to clarify because you told me that it wasn't so clear, and maybe the message that I sent is that you have to touch it or adjust it, and Okay. Okay. Thank you for coming. Thank you for coming. And thank you all the people that joined us through the live streaming. It was a pleasure to be with you to share these 2 days of training, and a privilege also to have people coming from different countries and making the effort to be here. I appreciate that, and I thank you. And for all the people who invested hours of his or her precious time joining with us through live streaming, thank you also. And we'll see you in future trainings and future meetings. Thank you.